Have you ever wondered why water sticks to itself but oil doesn't mix with it at all? The answer has a lot to do with polar and nonpolar covalent bonds. In this video, I'll explain what they are, how to tell them apart, and give you simple examples you'll remember. First, let's start with covalent bonds. A covalent bond forms when two atoms share electrons instead of transferring them. Atoms do this to become more stable, usually by filling their outer shell of electrons. I have covered electron shells and the octet rule in depth in a previous video. The link is in the top right corner. Hydrogen and oxygen share electrons to form water. That's a covalent bond. To understand polar and nonpolar bonds, we need one key idea: electronegativity. Electronegativity is a measure of how strongly an atom pulls on shared electrons. Electronegativity generally increases from left to right across a period on the periodic table due to increasing nuclear charge, pull. It decreases from top to bottom within a group due to increasing atomic size, distance from nucleus. Fluorine F is the most electronegative element, while cesium, Cs, and francium, Far, are among the least, leading to a strong trend towards the top right of the table. Atoms like oxygen, nitrogen, and fluorine pull very strongly. Atoms like hydrogen and carbon pull more weakly. The difference in electronegativity between atoms determines whether a bond is polar or nonpolar. A nonpolar covalent bond happens when electrons are shared equally between atoms. This usually occurs when the atoms are the same or their electronegativities are very similar. The following are examples of nonpolar covalent bonds: hydrogen gas, oxygen gas, methane. Because the electrons are shared evenly, there are no partial charges in the molecule. A polar covalent bond, on the other hand, forms when electrons are shared unequally. One atom pulls the electrons closer, becoming slightly negative, while the other becomes somewhat positive. Examples of polar covalent bonds are as follows. Water, carbon dioxide, ammonia. Oxygen pulls electrons more strongly than hydrogen, resulting in water being a polar molecule. This uneven charge distribution is why water has special properties like dissolving salt. Let's compare them quickly. As you can see in the image displayed, a nonpolar covalent bond involves the equal sharing of electrons. Therefore, there is little or no electronegativity difference. On the other hand, polar covalent bonds involve unequal sharing of electrons and a noticeable electronegativity difference. The bigger the electronegativity difference, the more polar the bond. Now let's test your understanding. Attempt the following quiz. Is the bond in hydrochloric acid, HCl, polar or nonpolar? The answer will be in the comment section. In conclusion, remember that T covalent bonds share electrons. Nonpolar bonds share evenly. Polar bonds share unevenly. If this helped you, please give the video a like, subscribe for more chemistry help, and thank you for watching.